So let's look at question number 3 of decomposition of potassium chlorate Prelab. So you want to find the theoretical yield in volumes of oxygen gas that's produced at STP when we have 0.920 grams of potassium chlorate decomposes. So basically what's asking is that you start with 0.920 grams of potassium chlorate. When it decomposes, one of the products is oxygen gas. Now we want to find the volume of oxygen gas in milliliters. So we're looking at a balanced reaction for the decomposition of potassium chlorate. And keep in mind that whenever we talk about quantity, it's all about mole to mole ratio. And in order to find the volume or the amount of oxygen gas produced, we're gonna do some stoichiometry here. So what I want to do is that from the mass of potassium chlorate, I'm going to find moles of potassium chlorate because we can't do a stoichiometry or mole to mole ratio unless we have moles. Now, based on the balanced reaction, we're going to find moles of oxygen gas. And once we find the moles of oxygen gas, remember that we're looking for the volume of oxygen. So let's do this step by step. So the mass of potassium chlorate given is mass of potassium chlorate given is 0.920 grams of potassium chlorate. Now, first step, I want to convert this to moles of potassium chlorate. So we're going to use the molar mass of potassium chlorate. So each mole potassium chlorate is about 122.6 grams of potassium chlorate. So mass and mass cancel out, you end up with moles of potassium chlorate. It's a step 1. In a step 2, based on the balanced equation here, I want to find the moles of oxygen gas that's produced. So based on the balance reaction, each 2 moles of potassium chlorate produces 3 moles of oxygen gas. So step 2, I found the moles of oxygen. Now the next step is finding the volume of oxygen. So how do I go from moles to volume? If you look at the problem, it says that this reaction is done at STP, standard temperature and pressure. And we know that at STP, the volume of each mole of gas, so each mole of any gas occupies 22.4 liter of that gas. So basically what it is saying is that only at STP, each mole of any gas, the volume of each mole of a gas is 22.4 liter of that gas. So I'm going to use this as my conversion factor to convert moles of oxygen into the volume of oxygen. And again, just because it is at STP. So I know that at STP, each mole of any gas, here being oxygen, occupies 22.4 liters. This is a step 3. So moles of oxygen cancel out. And look, we have the volume of oxygen now. However, the volume here is in liters, and the question is asking us to find the volume in milliliters. So I'm gonna do one conversion step here and convert liters to milliliters. And in regards to units, the only unit that you're gonna end up with is milliliters. Milliliter is a correct volume for a correct unit for volume, so that tells us that we set up this problem correctly. Now once you do the calculations here, you're gonna end up with 252 milliliters of oxygen gas.